Good morning, students. Myself, Dr. Eustace Russell, working as Assistant Professor in the Department of Mechatronics Engineering at Sri Muthukumaran Institute of Technology. So, in the previous video lecture, we have seen part 1 and part 2 video lecture of Unit 2, that is gear and gear trains. We have seen the basic definitions of gear, what are the classification of gear, how the gears are classified we have seen. Then in the part 2 of Unit 2, we have seen the length of path of approach, length of path of recess, and the length of path of contact. We have seen the basic formulas and the sliding velocities also we have seen. Today also we have seen, we are going to see about the gear trains, that is epicyclic gear trains, and the major classifications also we will see in this upcoming session. So this is the glimpse of the syllabus already we discussed in the previous videos. So first thing we are going to see about what is gear trains. Two or more gears are made to mesh with each other to transmit power from one shaft to another shaft. Such a combination is called gear train or train of toothed wheels. So we are aware of that it is a transmission of power from one shaft to another shaft. Such a combination will tell us a gear train. That is a series of process. Nature of the train used depends upon the velocity ratio required and the relative position of the axis of the shaft. Gear train may consist of spur, bevel, or spiral gears. These are the various types of gear trains. We are going to see one by one. First is simple gear train, compound gear train, riveted gear train, epicyclic gear train. In this, epicyclic gear train is the most important. In most of the university question, they will ask the question in epicyclic gear train. We will see in the this video as well as next video. We will see elaborate about this problem. Simple gear train. This sketch represents the simple gear train. The first is the driver and the driven. Second one is driver will also be there, driven will also be there. In between that, one of the intermediate gear is also there. That is transmission of power will be take place from 1 to 3. That is 1 is clockwise, 3 also clockwise, and the 2 is the anti-clockwise direction of rotation. And the last diagram represents driver 1, 2, 3, and 4. 1 and 4 having the same direction. 2 and 3 also having the same direction. The speed ratio is nothing but N1 by N2 is a reciprocal of T2 by T1. So if it is N2 by N1 means automatically it is T1 by T2. Ratio of speed of driven or follower to the speed of driver is known as train value of the gear train. Now that is see about compound gear train. Compound gear train. The axis, the same axis of the shaft having one or more gears. So that is this thing we can see. The compound gears, that is 2 and 3 are coming under compound gear. The 4 and 5 are the two gears are attached in the same shaft. That's why it is termed as compound gears. So we are the product of all the speed which is equal to the product of all the gear teeth. That is T1, N1 by N2. What is N1 by N2? That is nothing but T2 by T1. What is N3 by N4? That is T4 by T3. N5 by N6, T6 by T5. Upon multiplication, we can see some of the speed will be similar because it is attached in the same shaft. That is N2, N3 will get cancelled, as well as 5 and 4. N4 and N5 also get cancelled. Finally, you will get the expression that is mentioned in the slide. Riveted gear train. This is compound gear. One is compound gear. Another one is coaxial shaft. That is not attached together. There is some gap will be there. It is not connected. But this gear will be placed one before the another. Gear will be placed behind that another gear. 2 and 3 are rotating in the same shaft, and we are getting the transmission like that. So epicyclic gear train. Epicyclic gear train is nothing but the gear B that is revolves around gear A with the arm such as O1 and O2. that is called O1 and O2. The arm C that is connected with A and B. Here we can see where a gear A and arm C has a common axis at O1 about which they can rotate. Gear B measures with gear A and has its axis on the arm at O2 about which the gear B can rotate. If the arm is fixed, the gear train is simple and the gear A can drive gear B or vice versa. But if gear A is fixed and the arm is rotated about the axis of gear A, that is O1, then the gear B is forced to rotate upon and around gear A. Such a motion is called epicyclic, and the gear trains arranged in such a manner that one or more of their members move upon and around another member are known as epicyclic gear train. Here we can see arm is fixed. That is the assumption we are going to take. Arm will be fixed. Gear A can drive gear B. But if the gear A is fixed and the arm is rotated about the axis of the gear A, then the gear B is forced to rotate upon and around gear A. That I already told. B will be rotated around the gear A. So these are termed as epicyclic gear trains. So this tabular form is very, very important for solving the problems. In all the problems, we have to do this tabular column. We have to do some assumption. Based on that, we will get some ratios. You have to take the input and the output. What is output we are going to get? Everything we have to mention here. TA is nothing but the number of teeth on gear A. TB is number of teeth on gear B. The same thing, the first thing always we have to do that arm will be fixed. That is one thing, important condition. Gear A rotates to +1 revolution. We have to take as anti-clockwise direction. So arm fixed means 0. In some books they have taken anti-clockwise minus. Some books they have taken as positive. That is not a problem. What are the directions we are going to take? The final answer will be same only. Based on clockwise or anti-clockwise is not a matter. So minus TA by TB. Arm fixed gear A rotates to +x revolutions. So 0 plus x minus x into TA by TB. Then add +y revolutions to all elements. Finally, you will get +y plus y plus y. Total motion is nothing but we are going to add second row and the third row. You will be getting y, x plus y, y minus x into TA by TB. So without this tabular column, difficult to solve the problems. In the upcoming video lecture, we are going to solve the problems by using this kind of tabular columns. So these are the two references which I took for preparing this content. So kindly go through these references, so that will be more useful. So what is the summary we have? We can have a glimpse of the summary about today's video lecture. We have seen about the various classification of gear trains, how it is working. Then important thing, how we are going to solve the problem with the help of the tabular column. Some assumptions we are going to take, how the input is transmitted from one end to another end. We are going to see with the help of the tabular column. So thank you students for your kind attention for listening this video session. So we successfully completed 3 parts of this unit 2, that is gear and gear trains. In upcoming video lecture, we are going to solve some important problems in gear trains. So that will be very useful for you. That's as I already told, this is an important topic, the gear train. So kindly subscribe this video, kindly share to your friends. So we will meet in the next video session. Thank you all.